part of the project, failure analysis of materials and the marine environment, which has a purpose to explore the effects of the marine environment to the materials using experimental and numerical analysis. So, short outline. First, we had the experimental procedure, which consists of specimen exposure to the environment, visual analysis, mechanical tests, which were based for the numerical analysis that comprises modeling fitting corrosion, material properties, and finite element analysis. Experiment procedure was conducted according to STM G52 and G1. First one covers the conditions for the metals and alloys in open corrosion tests, and G1 covers the preparation, cleaning, and evaluation of the corrosion test specimens. The specimens were cut from the AH36, it's shipbuilding steel, and from a welded plate, and they were exposed to the marine environment for different prolonged time periods. They were put in the 10 meters below sea surface, and the sea tide location was on the northern Adriatic coast, and tap water in the laboratory. The changes in base material and heat affected zone and burn material of the specimens were observed. So here are some results from the visual inspection. It's the same image after 6 months. Specimen, base material specimen, as you can see, slash tight material. And the other one is optical microscope, also base material exposed to the sea for 12 months. The experimental results were collected into the charts for different environmental corrosion areas and over the time. So we can see that the main things happened in the first 6 months. After that, the depth doesn't change significantly. Beside this visual inspection, the mechanical tests were conducted before and after the exposure to the corrosive environment. And this was impact energy test and, of course, different finance testing. All these data were based for numerical analysis. First were the model of pitting corrosion was made using Poisson stochastic process, and special routine was developed in order to get such a corroded surface as model. As a fracture criterion was taken stress modified critical strain, which uses 2 parameters. First, alpha is material parameter and traxiality. Some scientists use also average traxiality, which takes into account also the previous state of stress. Material base metal properties are yield strength and ultimate tensile strength are given here, and alpha parameters from impact energy test using this empirical formula. The Goran model for the base material is in Bozic 5th, whose parameters are obtained from the tensile test and the fitting. For heat affected zone, we have also yield strength and ultimate strength, but it is obtained from the hardness measurements. And alpha parameter also from the impact energy test. And hardening models is power law. Which you can see here. For the welded metal electrode is AH36 wire, which has yield strength and ultimate strength also calculated from the hardness and alpha parameter from the impact test with corresponding power law hardening model. All these parameters were collected and put into the finite element program. We used solid 186 element. It's a tetrahedron 10-node element. But here appeared another parameter from its length scale parameter. That is a characteristic length, and this governs the size of the element. This parameter is a simple diameter of the fracture surface. So since it is 0.1 millimeter small, we needed a large number of elements. So there are some, here you can see some results. It's a C specimen, which was in the sea for 36 months. Here on the left side is welded metal and heat affected zone. On the right side is phase metal. And here you can see the initiation of the time crack. Another result we have here, it's tied after 24 months. Also, this is a welded metal and heat affected zone, and here is some model from base metal. And here we can see the beginning of the crack initiation. These diagrams, we develop first these diagrams and then the result, because the end of these diagrams are criteria for ductile initiation. So we have here for all these time periods in different corrosive environment, and also for the heat affected zone and the welded metal after 36 months. The tensile test visual report, this orange is experimental, and these blue ones are numerically performed tensile tests. The failure happened in the base metal in our cases. At the end, conclusion. The main conclusion is this, that using this criteria, we had increase in stress axiality, which decreases the critical plastic strain, and that is, as a consequence, we have earlier ductile fracture initiation. Most significant changes are after 6 months, and most affected is base metal. These results are very applicable for the assessment, design, and analysis and naval and offshore structure. At the end, I wanted you to invite to our Professor Bozic conference in Dubrovnik this September. So that's it.
Okay, thank you. Other questions, comments? Yes, please.
Thank you. You mentioned that you consider corrosion in your model, yes?
Yeah.
Corrosion
Yes.
influence in your model.
Yes.
Would you specify what parameters of corrosion you consider? It's only a surface damaging, or mainly, or maybe a hydrogenation process and influence on material?
Okay, this wasn't as a procedure for the reason why that's happened. It's not of interest. The pic is there. So why we monitored also the pH, the temperature, all of that, but the mechanism how the corrosion was initiated, that's not.
Only surface damaging, yes?
Yes, surface damage.
Okay,
Yeah.
thank you.
Surface and then the result for this surface damaging is initiation later for fatigue.
Yes, sir.
Only to make it clear, you didn't simulate the corrosion.
No. We take specimens, then we modeled using Poisson stochastic process distribution over the surface. But
So it was like a roughness.
Yes. But different size, depth, and after that, ANSYS and LS-DYNA, and we get this result. But corrosion as process, that wasn't modeled. That's another story.
Further questions?
You mentioned ductile crack initiation. Which kind of criteria did you use?
SMCS.
Okay.
This one. Stress modified critical threat. It's easy to employ in banks and program.
Further questions? Okay, then thank you again.